Hey, today we're going to talk about equations of parallel and perpendicular lines, and I'm going to reveal my true inner nerd because I love these types of problems. To me, it's like having the pieces of a puzzle and trying to put it all together to make it fit, and that is exactly what we're going to do. We're going to take some pieces of information and solve to create other equations of lines that are either parallel or perpendicular. So let's just start by thinking, what even are parallel lines? You know that parallel lines are lines that run side by side, like in the picture here, and they never ever intersect. So think about what that means for these lines. I've written the equation here, and there might be something that jumps out at you. Let's think about, what is the slope of this line? 2. What is the y-intercept? Positive 3. The slope of this line is 2, and the y-intercept is negative 1. Think about why these lines have the exact same slope. Well, the reason that they have the same slope, every set of parallel lines has the same slope, is because think about what the slope means. It means how much it's going up and over. So if they're going up and over at different rates, eventually they're going to intersect and therefore they wouldn't be parallel. But if they're going up, their steepness is changing at the exact same rate. So for every time this goes up 2 and over 1, this one's going up 2 and over 1. That means they're never ever going to intersect. So, key thing to remember here is that parallel lines have the same slope. Parallel lines have the same slope. And there's a little song, parallel lines have the same slope, parallel lines have the same slope, parallel lines have the same slope, never will they meet. Okay, so they're never ever going to touch, never going to cross each other. Perpendicular lines, however, they do touch each other. And the thing is, when they cross, they form a 90-degree angle. So perpendicular lines are not like this. That is not perpendicular. They have to form at a right angle. And what makes this happen is when I have slopes that are opposite reciprocals. So the slope of this line is 1/2. The slope of this other line is -2. -2 is the reciprocal of 1/2. So 1/2's reciprocal is 2 over 1. So these are reciprocals, reciprocals, reciprocals. Remember that word. These are reciprocals. And the fact that one is positive and one is negative makes them opposites. Positive and negative are opposites. So in order for lines to be perpendicular, their slopes have to be opposite reciprocals. One must be positive, one must be negative. One must be 1/2, then one must be 2. The other must be 2. So let's think about some other reciprocals. Let's say I have 2/3. What would be the opposite of 2/3? It would be negative, and its reciprocal would be 3 over 2. So these are opposite reciprocals. We could do 4. What's the opposite reciprocal of 4? Well, we know 4 is understood to be 4 over 1. So the reciprocal would be 1/4. Since this is positive, this has to be negative. And these are opposite reciprocals. And it doesn't matter what their y-intercept is. As long as their slopes are opposite reciprocals, those lines are going to intersect to form a right angle. So let's take that information now and gather some puzzle pieces together and try to fit them together. So this problem tells me we have a parallel line that passes through this point, and it's parallel to the line of this equation, to the graph of this equation. So let's think about, what do I need from this? Do we care about the y-intercept? Nope, means nothing to me. The only thing I care about is the slope, because I know that parallel lines have equal slopes. So my new line is going to have a slope of +3, since they are parallel, they have the same slope, and it's going to pass through the point -4, 2. So now we're back to the previous topics that we were covering, where we need to write an equation. So there's a couple different ways we can do this. We can plug in y minus the y coordinate. Makes sense to me since I have a point and I know the slope to plug it into point slope formula. So that's exactly what I'm going to do. And then I'm just going to go ahead and simplify it into slope-intercept form. So distribute 3x plus 12 equals y minus 2. Add 2 to both sides. So y equals 3x plus 14 is the equation of the line that is parallel to the graph of this equation. All right, moving right along. That helped us figure out parallel lines. So what if it says it's perpendicular? Well, we know that perpendicular lines have slopes that are opposite reciprocals. Sorry, I had a visitor pop in. So back to looking at this, we're looking for perpendicular lines. Well, we know that the perpendicular lines have slopes that are opposite reciprocals. But glancing at this equation, oh, I'm going to have to work, right? That's what we all think. Work. No, it's easy work. We just have to get this in slope-intercept form. Right now it's written in standard form. So I need to move the 3x over to the other side. I'm just going to do a little bit of algebra, something we've been doing all year long, right? This is Algebra 1. And now we're going to divide everything by 2 to get the y entirely by itself. And I don't even care about this stuff. I'm just focused in on this. So if the slope of this line is -3/2, then the slope of my line that this says parallel, it should say perpendicular. The slope of the line that is perpendicular to it should have the opposite, so we know it's going to be a positive, and be the reciprocal of this. So what is the reciprocal of 3/2? Well, it's nothing more than 2/3. So see, these slopes are opposite reciprocals. Now I'm done with this. That's the only reason I needed this, was to be able to find the slope. Now that I know the slope, I'm going to use my new slope that I found, and I'm going to use my point. Again, I've got the point and I've got the slope. Y minus the y coordinate minus the -2 becomes a positive, equals my slope of 2/3 times x minus the x coordinate. And technically, we could stop here. It just said to write an equation, but I like to write mine in slope-intercept form. That's my favorite. So that's what I'm going to do here. So I've got minus 2/3 equals y plus 2. I'm going to subtract 2 from both sides. So y equals 2/3 x, -2/3 minus 2. Now think about it. 2 is the same as 6/3, right? So -2/3 minus 6 more thirds is -8/3. So this is my equation written in slope-intercept form. And I believe that is pretty much all that we needed to do. Now, if it had asked me to write it in standard form, just want you to think about this, kind of challenge yourself. If you're not in the mind to challenge yourself, you can go ahead and stop watching this video. But for those of you who like a challenge, think about converting it back into standard form. What we can do is multiply by 3 to get rid of that crazy fraction. So we're going to have 3y equals 2x minus 8. I just multiplied every single term by 3. And this 3 here would have canceled, and it would have canceled with this 3 here, leaving me with the 2 and the -8. Now to put it in standard form, we need to put the 8 over here. So it's a positive 8, and bring the 3y over here. So it's a minus 3y. Remember, we want this x to be a positive number. That's why I didn't move that over there. You could have and then multiplied everything by -1. That would work too, but we want this to be positive. So we have 2x minus 3y equals 8 written in standard form. All right, so that is all I have for this video. I hope that this made sense, that you enjoyed it, and if you have questions, let me know.